I said that we knew we would find organics on Mars, and it was a question of which ones. What was the reason behind our feeling? Can we see the next one, please? We know, as I mentioned, that the Miller-Urey type reaction does produce organic compounds. And it was generally thought, as you heard earlier, that the primitive Mars atmosphere was similar to the primitive Earth atmosphere, and therefore it was a foregone conclusion that Miller-Urey type products would be formed. We had even a more dramatic example. In creating one of the life detection experiments, which looked for the incorporation of radioactive CO2 into microorganisms, looking for photosynthesis, the experimenters found in their preliminary work that when sunlight shines on Martian atmosphere, organic material is produced. Not only is it produced, but even in the face of the persisting ultraviolet portion of the spectrum, it accumulates. So here we have the strange phenomenon that the ultraviolet light is not destroying the organic material, and just shining the sun on Mars should be producing organic materials. And these experimenters said that on Mars, the amount of organics produced over geological time, shouldn't have used the word geological, about, I guess, Marsological time, but they said geological time could be significant. Indeed, it could. We know that there's an influx of organic materials from the early barrage of meteorites and comets and the continuing fallings of these bodies which bring organic compounds to Earth. These objects have been found, analyzed, they have organic compounds. The same thing is happening on Mars. The craters that you saw, some certainly were made by objects containing organic material. Where is it? More recently, in the journals, you will see there's a class of meteorites called the SNC meteorites, which by isotopic analysis and chemical analysis have been generally accepted as coming from Mars. They were ejected from Mars by some of these meteorites, which you saw making the craters on Mars, and they sprayed out with energies taking them out of Mars in a variety of directions, some of which were directed towards Earth, were captured by the Earth's gravity field, and deposited on Earth with organic materials intact. These SNC meteorites all have organic materials in them and are identified as having come from Mars. So here we have organic material that we believe came from Mars that would certainly say there ought to be organic material on Mars. And finally, we have these tiny dust particles, interplanetary dust particles, that are bombarding Earth with some thousands of tons per year, and they have been identified as containing complex aromatic organic compounds, some of them with mass units as high as 670, and the same thing must be happening, although to a somewhat lesser extent because of the lesser gravity, on Mars. So all those reasons say, yes, there are organics on Mars, and indeed the experimenter of the instrument that went to identify those organics, the GCMS instrument, gas chromatogram mass spectrometer, said that yes, there's good reason to identify those organics because they must be on Mars. The way this was to be done was just as is the case with the LR experiment. That same arm scooped up some soil, put it into a tiny oven, very tiny oven, 600 milligram content. And the oven was then turned on. If there were any organics present, they were evaporated. They went through a gas chromatographic column to separate them into discrete segments, which then were fed into a mass spectrometer for identification. The instrument was a marvelous attempt at miniaturizing something which on Earth in our laboratory is about almost 5 times as big as this whole podium. And that instrument was placed into something far less than a cubic foot. And you had to give up certain things to do that, amongst which are sensitivities and the ability to look in particular areas and discriminate. The GCMS data were eagerly awaited on Mars because obviously they would have great importance with respect to interpreting the LR data. And the next view graph shows we all waited and absolutely no organics were detected as indigenous to Mars. Some organics were detected which were a contaminant in the instrument from Earth from its cleaning process, but nothing that could be attributed to Mars. The only compounds detected were carbon dioxide and water. And because of the mode in which the instrument was operated, the experimenter said that the values for water at the VO1, at the number 1 landing site, are very less precise than at the number 2 landing site, and the mode in which it was operated at lander 1 prohibited determining carbon dioxide. So the only results pertinent are those at Viking site lander 2 with respect to water and carbon dioxide, the only compounds detected. Moreover, these analyses were run at different temperatures, 200 degrees C, 350, 500. Then the same sample under the rock where we got a response was run 50 degrees, 200, 350, 500 in an attempt to see how the increasing temperature drove out the volatiles. Now the problem was to do that, days had to separate each heating. So it wasn't a continuous heating. You would heat and then you'd wait, let the thing sit around, and then heat it again. What happened then was a theory was proposed as the peroxide theory to explain the LR and the GCMS results. The theory is that in the upper atmosphere of Mars, the sunlight disrupts water molecules into hydrogen and hydroxyl ions. 2 hydroxyl ions unite to become hydrogen peroxide. The hydrogen peroxide falls down to the surface of Mars, where it does 2 things. It gets scooped up in the material that we put into the LR, and the hydrogen peroxide reacts with our nutrient to give us a false positive. And also, the hydrogen peroxide consumes all of the organics, which explains why the GCMS found no organics. The sensitivities of the 2 instruments, however, are instructive. In order to detect organic matter, the GCMS requires the organic matter equivalent to that provided by 1 million bacteria. It doesn't matter whether they're living or dead, unless, like Chris's fossils, the dead ones might have lost a lot of their organic matter. They've got to still have the organic matter. You need the organic matter equivalent to 1 million bacteria. The LR finds 10 bacteria and doesn't require any growth. That's the whole rationale behind its extraordinary sensitivity.